Hello and welcome to HackerRank Interview Preparation Kit playlist. We are currently in dynamic programming section. This is the second problem, that is abbreviation. It is marked as medium and for score 40. So we will discuss this particular problem in this video. And the last video which I made, that was max array sum. It was well received, and there I followed a technique, or we can call a basic flow. I discussed the base case or the base problem, and after that I showed a variation. So I discussed cadence algorithm, and then showed how that particular problem can be solved using that cadence algorithm basic skeleton or the approach. So I am thinking of doing similar approach here. So I'll be discussing the basic case first for this particular problem, and after that we will see how we can derive a solution from that particular base case. So for this particular problem, a base case or the base problem will be LCS. I don't know why birds are chirping so much, so I'm really sorry. I can't do about anything about it. So let's start. So LCS is longest common subsequence. So let's try to understand that particular problem first, and after that we will come to this particular problem, and we'll see how it is different from that LCS and what we need to do things differently in order to solve this. So before going to that part, so many people will believe that this particular problem is more analogous to longest common substring rather than a subsequence. But in reality, longest common substring problem is also derived from the longest common subsequence. So I hope we are targeting the parent problem or the base problem, so that in future if you see many variations of this particular problem, you can go ahead and solve it. So let's start. So first let me go on paint. So this is basic flow will be. So we'll discuss LCS, and these are the terms which I'll be discussing with you shortly. And after that we will go to the problem. We'll see the problem definition, the variation, and how we will solve it. And lastly, we will write the code. So first thing first, many people might be confused in what is subsequence and what is what is called substring. So, and one more thing, because this is the second problem, and many of you might be well known with the LCS problem because it's quite popular. So I don't want you guys to waste time. So what you can do is, if you know the particularly LCS formula or the basic LCS approach, you can directly skip to the solution. So I'll be adding timestamps in the track, so they will be available somewhere here. So you can directly start with problem definition. So it will save you time. Okay, so let's start. What is the basic subsequence and substring? So let me take let's say take example. So let's go with PA, QB, and RC. And this is the first string, and let's say second string is ABC. So in this case, the longest common substring will be only one case later, because we will check if whole ABC is present in this particular case. This will be the problem of substring, because we are checking the whole string, and whenever we are checking subsequence, so in this case you can see that our A, our B, our C are present, but they are not in the what you can say continuous loop. In substring we want them to be a continuous loop like this. In subsequence we want them to be a sequentially but not contiguous like this one. So I hope you got the basic logic. So subsequence means our elements are present but not contiguously, but in the sequence wise manner. So I don't want that like C PA. If that was the case here, it would not be counted as a subsequence. However, because they are in sequence A, B, C, it may be next to each other, or maybe somewhere in the future, but that needs to be a sequentially. So this is a basic subsequence, and this is a substring which are near to each other. So I hope you got the basic explanation for this. It's not quite necessary, but if any one of you had a doubt, I hope that got it. So in order to solve the LCS problem, there are various approaches. So you can directly go with the basic approach or the brute force approach. That will give you the time complexity of 2 to the power n. After that, you have recursive approach, where you can achieve that time complexity into m into n terms. And after that, a recursion, we have again one method, that is iterative. So again, I think iterative is more intuitive and better approach than the recursion, because there are some complexions with the recursion. So it again solves the problems into m into n. Or because many people are more familiar with the iteration, and in this case the iteration is also a better choice to go with. So we will use memoization. So all the techniques I am saying that I have discussed this in the dynamic programming video, that is slide. So we saw the difference between the recursion and iteration and when to go with which one. So I'll add the link here so you can go and watch it. So in this particular problem we will go with the iteration. I'll show you how this particular problem works. So like this thing is done, this thing is done. After that a table creation. So let's go on the problem so we can focus there. So let me take a problem, the same problem which we discussed, that was PQR, I guess. This is the first string, and the second string will be let's call it as ABC, because at the end of the day we have to solve the problem, not to go in depth with the LCS. So these are the two strings. We need to find the maximum common subsequence between these two. So what my approach will be, I can go with the brute force approach. I can check one by one, so it will go into exponential terms, or I can go with the recursion as I discussed. That will also land in M into N. So again, we can solve this particular problem using DP, and because we are in the DP section, we are meant to solve this particular problem in DP. So let's go ahead and create the table. So many people might be confused with this particular table, why we need it and why we do it. In DP, we saw that it is a basic recursion or the iterative method with some common sense, and what that common sense was, storing the values, because we don't want to repeat the computation for each term. So let me draw a basic table. So I'll show you how this particular problem can be worked out. So this will be P A Q B, and I think there is a space crunch. I'm sorry, I didn't thought it through for trying. So this is the first string here, you can see, and after that we have like basic 4 columns here, like 4 rows here. Let me draw it first, or I should have drawn it with the paint standard table. So this is the first string, this is the second string. We need to find the subsequence. So in this case, what we generally do is, when the first is, that is 0th element, if we don't have any elements in each other, that means we don't have any subsequence or any matching character. So that means it will be basically 0 or the null condition. So pay attention here, because when we will be solving the problem, it will be necessary to check the base condition, and many people whom I see solving DP, many get stuck at the checking at the base condition. So this is a thing. After that, the whole row will be 0. Why? Because it is being compared with a null value. So that means there is no subsequence present as of now. In the first what we have said, not while instancing this particular matrix or the table, we will initialize all the values to 0. So that is not the issue, but these values which I feel, which are being compared with null, are needs to be written with 0. So I hope you got the particular logic why I feel 0. After that, we'll see what we are basically do is, let's go with I, or you can call it as I in the for loop, or call it as J, or whichever you want, because that's not really an issue. So let's start. First, we will let's say start with P. So here P is being compared with A. So what this particular table or box means, P and A being tracked. This particular box, what it describes is, PA is being compared with A. So let's go ahead and start. So what we will do, if P and A matches, we will let me write a basic formula here, so you can get more help of rather than just seeing. So I have written the basic formula for you guys. So we will see how it works. So first, all the values of row and columns are initialized to 0. In fact, all the matrix is initialized to 0 in the first. However, these are the important conditions because they are base conditions. So let's start. So if these two are matched, we will add the 1 plus the last diagonal value. And why last diagonal value? This is the last diagonal value. So why last diagonal value? Because we are carry forwarding the value. We are counting how many instances are possible and how many values can be matched. So let's see. So let's start with P and A. So P and A will be compared. If they match, no. So we will go in the else part. So in this case, we will choose maximum between the last column and last row. So in this case, so let me take a different color. So now Here the value will be filled with 0. So what we initially do is we just compare between A and B and we check if there is any subsequence present in these two. No, hence we return value 0. After that we will come at this particular point. Here we will be checking subsequence between A and P and A. Is there any subsequence? Yes, we can say that there is A present in the both. So in this case, because these are two matched, we will do 1 plus the last diagonal value. This will be 1. So this particular one box or the one value represents the number of common elements in P, A and A from this particular string. After that we will go at Q position. So again it will be compared between P, A, Q and A. We know that is a very single element is present in both of case. So in this case what we will do, because they are not matching, we will take the maximum value from the diagonal. So this will be again 1. After that we will come at the B's position and we will check if there is any subsequence present here. So that is only A present. So what we will do, sorry, not do. So we will just carry forward the value, that is 1. Similarly for C it will be 1. Similarly for R it will be again 1, because we are carry forwarding the last row or last column value whenever the item does not match. So this is for the first column. After that we will go with second column. So now we will be checking A, B with the rest of row. So first let's say P. This particular column or the table represents the comparison between B and P and AB. So let me write P. So let me go AB here, because first string is long. So AB is being compared with P. There is no match between these two, no subsequence present. Hence we will fill the value 0, or it's already initialized with the 0, so there is no issue. Or we can bring the maximum value between the last row and column. It is again. After that, AB will be compared with PA. Right? PA will be compared with AB in this case. So we can say that A is present, that is one sequence is formed. And how we can go around this in programmatic manner? So we will fetch the last maximum value between last row and last column. So this will be 1. After that, it will be similar for Q. Similar. So let's so this will be PA, QB, and A. So in this case, we can, like, because this is a small problem and we can come at the solution with the intuition, we can see there are two subsequence present, that is A, B, and here A and B. Okay. So how this particular solution will work? If the both elements are present, we will add +1 to the last value, the last diagonal value. So in this case, it will be 2, because 1 plus last diagonal value. So what was last diagonal value? 1. And what it was comparing A with PAQ. So until this point, so let me change color. The last point was being discussed with A and PAQ. Now B is added on the both sides, so hence we added the value 2. After that, it will be similar for the C and R. We will fetch the maximum value present from the diagonal, that is row and column. So it will be 2 and 2. After that, now the whole A, B, C will be compared with P. So let me write here A, B, C will be compared with simple or single P. So we know that there is no match, no subsequence present. So again it will have the value 0. After that, A, B, C will be compared with A. So at any point of time, what you can do is, in order to understand, you can see at this particular joint. So it will show you how values are being considered. So if you go up above the ladder or in the columns, you will see it will comparing PA on the left hand side, ABC. So we know that there is one subsequence present, and how we know that? Taking the value maximum from the row, either row or last column. So it will be 1. Similar for this case, we will take the maximum out of these two. Now the maximum out of PAQB and ABC will be 2. That is AB is subsequent, so it will have the value 2. Now C will be compared with C again. So now we are comparing whole string, this string with this string. So we know that there are 3 subsequence present, A, B, C. So what we will do in this case, because the items are matching, that C and C, we add 1 plus the last diagonal value. So it will be 3, and again the last value will be out of maximum of the. So this is the basic subsequence problem. I hope you guys understood it. And I did not go in the detail, I know that. So if you want to know more about this problem, you can go ahead and check it on Geeks for Geeks. or you can either watch video of Abdul Bari. He have explained it in a much better way. So I hope he has a video because I watched it very long time ago. So you can go there and watch it. So I'll if it's present, I'll add the links in the description. You can go ahead and watch. So after this, we can again trace back which were the values present. But then this is not necessary for my current problem, right? So we will not go deep into that. And one more fact that may like fun fact, because you might be get tired with this particular explanation. So whenever we feel the values from the top to bottom, it's bottom up approach, and whenever we feel values into the table from bottom to top, it's a top down approach or the recursive approach. So we discussed what is top down and bottom, difference between these two. So we are discussing the dynamic programming, like the basic theory slide. You can check the so I'll add the links in the description, so you can always go ahead and check that. So I hope you guys are now comfortable with what LCS is, how you can go ahead and find this particular values. So this is the basic formula or the iteration which we are going to do. And before writing this, we will have the two for loops, that one for I or one for J. I hope now that you are mature enough, because you are solving dynamic programming problems. I hope you know the basics of solving the problem, and this was the crux of it. So I hope you got the logic. Now let's move ahead to our current problem. Okay, now let's focus on the current problem, that is abbreviation. So let's discuss the problem definition. Here you will be provided two strings. So let's start with the problem definition first. So in this particular problem, we will be provided with two strings. So that will be A and B. So we saw what are these two, and we saw what is the LCS problem. So in this problem, in the A string, we will have this kind of problem where it will have the mix of capital letters and small letters, and the string B will have mostly of like capital letters or any letters, and we have to match them, not to find subsequence, but to find a substring. So we want the exact match of B in C or like in A. So we will see how it can work. And after that, there are two operations are possible. So in string A, we can for the small case letters, we can either go and delete that particular letter in order to match B to A, or we can go ahead and capitalize. So there are two methods which are available. So they have given description here. I hope you have read it. So one more condition from me. So one might people misread, and I first time when I solved this particular problem, I did not initialize did not realize that we cannot delete the uppercase letters from the top. So this is the case. So we can only delete the small case letters, or we can make them uppercase, and no deletion from uppercase letters from string A. And we need to match the string B to string A. So I hope you got the problem definition. So let's go ahead and start solving this particular problem. This is good. In the last problem, what we did was we incremented the value, that is 1, we can see here, and in the end we would have get the like 3, 4, what was the result, and that many number of subsequence was present, that number of common elements were present. So that was the case for the last problem. So in this case, let me take the example from the folder. So it is B, A, capital B, I think. On the left hand side, it will be capital A. So this is the example from the hackerrank in the test before. So I will be taking this for particular. So in this case, what are the differences? First difference is the no carry forward. Why? Because in the last problem we were discussing, that is the subsequence, and there we carry forward that value which was like 1, 2, and in the last we got like 3, 4, and that represented how many common elements. So in this case, our aim is not to find the number of common elements, but to find the exact elements, that is this particular string, to find the exact string present in this particular substring or the subsequence. So in this case, we will not carry forward the values. So what we will do is, so we will use the binary notation, or you can always choose to go with 1 or 0, whichever you like. So in the end, what will be my solution is, if I get true here on the last block, that is 1, that means this particular string is present here. If I get 0 or false, that means my string is not present here. So as simple as that. So this is the first condition. After that, let's move over to the second condition. And second condition is initial case or the base case. So rather than writing initial, I should have written the base case, but that's okay. So initial case. So in the last term, we saw that we initialize all values to 0 and then all first columns to 0, because there if both the strings were null, that means there was no subsequence found. However, this is not the case here. Here our aim is to find the maximum or if the strings are matching or not. So for this particular point which is null, again, that means both are null, and for me, for a distant observer, it is the same thing, right? If both values are 0, that is same to me. So that in that case, it will be a what you can say true case, or will be a valid case for the problem. So I'll initialize 1 here. After that, for each element in the first strings, so let me follow the color code which I am going to write. So on third case, it will be the case of small case letters. So here in this particular problem, I have liberty to either delete a small case letter or capitalize it. So let's see how it will work. So let us see this particular base case first. So here for D and a null value, I'll compare them and I have to field value, that is 1 or 4. If they both match, I'll have to field 1. If they do not match, I have to write false or 0. So what you guys think? It will be 1 or 0. So those who are thinking it is a 0 are quite wrong. Why? Because for each small case letters, I have two possibilities, right? I can either go ahead and make them upper or Q, or I can go ahead and either delete it, right? So in this case, I can choose to delete this particular object. So in that case, it will be a null string compared with null string. So this will be 1, right? It is the same. Similarly for this, I can go ahead and delete it. So null string will be compared with null string, again. However, for B, we know that B cannot be deleted because it's capital letter in the first string. We cannot delete it. So it will be compared with null strings and they will not match. So in that case, it will be a 0. I hope you got this particular logic. Again, C can be compared with null. This is 1. This is 1. So we initialize the base case or the initial case for the small case letter. So is there any other difference than that? I don't think so. But if I come across any difference, I'll go point it out. So let's take that. It's quite advanced, or I should have tell you in the later part. But let's. So in this last case, what we were doing was carry forwarding all those values. So in this case, because we are exactly looking for this particular string, what we will do is we will only update the value when we have this particular value to be true. So what this particular statement means is, let me take a small table and show you. So let's call it as A, B, C, and I'm trying to find the exact match for A, B, C, right? A, B, C. So in this case, if my previous term matches, then only I'm going to advance or write 1, right? Because last terms are matching, then I'll check if both strings are matching. If yes, then in that case only advance. So that will mean I have AB above and similarly AB in the downstream as well. So if this does not make sense, please be patient, because in the end of the day or in the end of the video, I'm going to fill this particular table, so you will get this particular concept. So what I mean to say is, I'll only update the value or write true values in the case of matching. I'll check the previous case if that particular matches. If that is the case, I'll update the value. That is 1. If not, so what will be the else case for this? Else case will be copying the value from the above. Okay, so we'll see how it will work. And for this true case, there may be two cases that it might be first, that is what is I'm forgetting the name, that is big capital letter. So we can directly go ahead and check it. If a small letter, we have to make it a capital letter and then check it. So I hope you got the basic working of this. So let's see how can this can be worked out. So let me clear the clutter. Okay. So my microphone was got disconnected. So I'm starting it new. So I hope you got the 4 conditions that was necessary. No carry forwarding initial case that we initialize values to it, and then we will again initialize all the values to 0 in the start. So this is the first case. After that we saw that small case and for there. After that we saw there was like true case or the else case, where we will check if the previous value was 1 or true. If in that case only we will be carry forwarding or taking value there. So for your simplification or my simplification you can call it, I have written the basic formula which I wrote like this, so we can make the comparison and we can check where we did the variation. So if we see here, it was like straightforward, but because we will be having 2 cases, that is small case letters and uppercase letters. If the particular problem was to uppercase, it would have been the same problem like this. The same problem, we would only check the values if they would match and the previous value was true as well, then we carry forward the value or initialize it to 1. So this was the case. Now we have to deal with the small case letters as well. So in that case, what we will do, we will take another else or to the if. So in that case, we will capitalize the particular letter and we'll check if that particular matches with the string. If not, we will initialize the previous value, that is whichever it is above. If not, like if it is a sorry, I just don't know what I said. If that particular matches, we will initialize that value to true or 1. If not, we will check how it will work. Okay, or assign the value accordingly. Now we will first come across this particular point. We will add D position. So we'll check if it's upper, no. So in this case, we will go to the else loop. We will capitalize this particular D to the T, and now we will check D to A if they both matches, no. And the previous condition is true, but because it's and it does not matches, we will go to the else part. So here we directly copy the last previous value, that is this one. So we mean to say that if this particular value is being compared with null value. After that, we will come across this. So we'll check if it's upper, no. So in this case, we will go down in the else part. We will capitalize letter A. So we will check if A and A matches. Yes, it matches. And the previous diagonal value matches or not. So in this case, yes, it matches. So in this case, we will initialize value 1. So this particular string represents between A and DA, we have one value that directly matches with this particular string, and that is A, right? After that, we will come at B position, we'll check. Because B is upper, we can directly go ahead and check. So B and A, it does not matches, so we will assign value 0. And we don't have to check the last condition or if last is true or not, because we are dealing with AND condition, we no need to check last. So after that, we will come at C, it is not uppercase, so we will go into else loop, we will capitalize this. This will be basically C. So C and A does not matches. So in this case, we will go into again else loop, and in this case, we will copy the top value, that is 1. Copy the last value, not from the top, but from the side, because I have forgotten this was the I and this is the J. So we will check the last value. So this means if I were to compare between D, A, B, C and B, I will not get the string at this particular point. Why? Because I cannot delete B, and B and A will not be matched. After that, we will do the same. So D will go into the second loop. It will be capitalized. We will compare it with A, does not matches. We will carry forward the left value. So it will be 0 again. After that, we come to this particular point or this particular string. D and B will be compared and they do not match, right? So in this case, again, we will copy the value, it will be 0. After that, A and B will be compared, they do not match in this case. So again, like even if we do the capitalization of it will not match. So we will copy the value from the left directly, so it will be 0. After that, we will check these two values. So we know that B is directly a capital letter, so we don't have to go into else part, so we will directly check it here. So these two matches, like B and B, and the last diagonal value, it is also matching. So that means we can go ahead and write 1 here. So this means AB from here is being compared with AB from here. So we can see in the diagonal term. After that, we will check C with B, it does not matches. And in this case, what we are going to do, we are going to copy value from the left hand side. So that means if we are going to compare between DABC and AB, we have value 1, that is means 2. And what it is? The capital A and capital B. So we can capitalize A, and in this case you can see that we can delete and C. So in that case we will get the true value. I hope you got the logic. After that it will be again compared with D. We will copy value from the left. So similarly D and C will be compared. So it does not matches 0. C and A does not match compared 0. D and C does not match compared 0. C and C, yes, it matches. So here's the small case. However, in this case we will capitalize it, then check it, it will match. So in this case we will check the last diagonal value, it is again 1. So in this case we will add 1 here. After that we will move forward, it does not matches. So we will copy or carry forward the left value, it will be 1. So in this case our last term or the last value is 1 or 2. So that means we have this particular string present here. And what are those values? A, B, C, where we can capitalize A, B the capital in the first place. We can capitalize C, and we can go ahead and delete D and D from here. So we'll get the same string. I hope you got the logic. So after that, this is the whole crux of the solution. You can write it down, or I'm going to write the code for you, so you can go there and check it. So I hope, because I wanted to take another example as well, but I'm feeling that this video will be long enough. So let's go ahead and write code directly, so we can save time and I can explain more things there. So let's start with the basic writing code. So I'll be covering this in a hurry because I think video is quite long. So many people do not tend to watch long videos. So I'll try to cover all the things important as possible. So if you have any doubt, do let me know. I'll be very happy to clear. So I checked two conditions. So the test cases, it will be in the range of 1 to 10. So we will have first variable for that. After that we have the strings. So they can be in the range of 1 to 10,000. So that is again good. So we don't have to take the longer variable for the container. So let's start focusing on this particular problem. So let me write the boilerplate. The test case I should have gone with T. So that's not an issue. So we got the while case. So here we have to take two strings. So not capital S, we are writing in C++. So this will be A and B. We will take input for both of them. So this will be A, B. After that we will try to find length of them, length of strings. So it's a good practice rather than writing string dot size or string dot length in for loop. We will go ahead and have the two, let's say, variables. So len A for the first string. So this will be A dot size. It will return the length. Similarly, len B for string B. So if you look closely in the last explanation, we started with 0 value and then ended with like last loop or the last value, that is m into n. So we saw that we compared the value that was from the first, right? We had the null value in the first. So in this case, what we will do is we will add +1 to it. Why? Because we want an extra column, an extra row while we are doing the computation. It is not necessarily required, but you have to do the modification accordingly. So that's why I have taken it. So after that we have to initialize the matrix. So let's call it as PP as all the peoples do. So it will be initialized to value of len A and len B. That's why we have added +1, because we want it here in the matrix. After that we have to initialize all the values to the 0. So we can either go by one with loop, or we can directly use function that is mean set. It is used to initialize value to either -1 or 0. So you can go ahead and write PP 0 and the size of P. I hope everything is clear until this particular point. After that we saw that. So let's again try to go with the flow. First we discuss that initialization of small case values in the table. In its small case, let me write. After that we saw for uppercase comparison. After that, we saw lowercase comparison, and there we check two conditions. That is, first we'll try to uppercase it and then check it, and then if not, we'll carry forward the value. So please excuse my grammar or spelling mistakes in the comments. So I did not to write them accordingly. So that is the case. And first case, before this particular first case, initialization of first rows and column. That is first case, right? Init of matrix. Let me put that. So first we have to initialize the value. First thing first. So we know that we have taken the first value of I, that is 0. 0 will be initialized to 1. We saw why it is. We compare both the null string, it will give the same results. This might not be the same case with the JavaScript, but in C++ it will give the result same. After that, let's focus on initialization of small case, not small cases, small cases. So how we can do this is, we'll take the basic for loop. I hope everyone is good at iterating, because you are solving TP problem. So that's a level. That basic level is expected of you. So in the small case, how we can check it? Let's take a if. You check if lower, we'll pass the value of a of I minus 1, because we are starting loop with 1. So if this particular value is true, I want to assign value of TP of I and 0, that is first row, that is initialized with 1. So we'll check if the particular character is lowercase. In that case, in the first row, we will assign value 1. So this is done. After that, let's move forward to the more complete solution, or like basic crux of particular solution. So we will start with, let's say, one for loop. I should have copied it, but that's not the issue. So let's go and write me as fast I can put. So here I'll having another loop. So for j is equal to 1, j is less than that of then b, j plus plus. So here, as we saw in the flow as well, first we'll check for uppercase comparison, and then we will check the lowercase. So first we'll take the if, we'll check if the particular given case is upper, and let's pass the value of a of I minus 1. If this particular case is uppercase, and I want to check that the whole values can be met or not. So in this particular if, what I want to write is, if my value at I minus 1, a of I minus 1 is equal to b of j minus 1. I hope this is making sense. And the last value or the diagonal value is 2. So in that case only we will be able to carry forward. So how we can write this is dp of I minus 1 and dp of like j minus 1. So because we are using AND condition, both of them need to be true in order to work. If one of them fails, the value will not be going into this particular if. So if this is the case, what I want to do, what I have to initialize the values to I and j. This will be initialized 1. So I don't think there is any requirement of taking else loop here, because we will just simply check if there is a matching or not. If not, we will not be bothered, because we have initialized value 0 to everyone in the mean set question. So I hope you got there. So let's write else condition. So in this case, I'll again have two options. So first I want to check if I can convert that small case letter to uppercase and then check for it similarly, or I can go ahead and carry forward the value which we saw in the expression. So first thing first, we will check is upper. So not is upper, we will convert it to upper. After converting, so let me write it completely first. After converting this particular value, so to upper ends here. So I want to compare this particular value b of j minus 1, and no, I should have written outside of this particular bracket. So we will compare this value to b of j minus 1. If this matches, and the same case being carried forwarded, if the last case is true, in that case only we will take the value. If this particular case is met, we want to initialize the same value, right? So this is the case. After that, let's say if particular case is not met. So in this case, what we were doing, we were simply copy pasting last value, that is from dp of j I minus 1. So this will be, let me go ahead and write it, dp of ij will be dp of I minus 1. So I hope you got the logic of the whole problem and this particular two for loop. So let me check where was my while ending. We can write. So you can just click on the loop. You will see this is the like my while ends. So before my while ends, I have to print the values also. So in this case, what I'll do is I'll simply check if I have a value at the end of the string or the end of the loop in the matrix. So how can I do this? I'll check if the value exists in len minus 1a and dp of len b minus 1. If we have value here, so that means we have got the substring present, so we can directly print out the result that yes. We will write endl because there are test cases involved. If not, we'll simply write cout no endl. I hope this particular code is good and it will work. If not, we will surely improvise that we are this too. So let's check for it. Compilation error len a len b is on the line. So yes, I have written it one more time. So let me go ahead and clear this. This dp of len a minus a, then this will be len b minus 1. So let's go ahead and check this. So it passes the basic test cases. So let's check for the hidden test cases. I know this could be a quite long video, and I tried to comprise whole lot of concepts in like cram them as much as possible. So if you feel there is any doubt or if anything you did not understand, do let me know in the comments. I'd be very happy to help you there. And thank you for watching. Have a great rest of the day.